Hi friends, good morning. Today we are going to discuss some problems in vector analysis based on lecture 1 and lecture 2, right? Alright. So here the first problem is the moment of force, right? Moment of the force, right? That particular force is given, right? Particular linear force is given. 4 I cap plus 5 j cap minus 6 k cap at 2 0 minus 3 about the point 2 minus 2 minus 2 is given by. Alright. Now what is moment of force? That is basically torque, right? What is torque? Torque is equal to R cross F, right? Torque is equal to R cross F. What is R? R is the line joining this at the point, right? This point to this point, right? That means position vector of this minus position vector of this. All right, that is that line, right? Now this is the linear force. All right, now you can substitute 2 minus 2. What is the position vector of this minus this? R vector, that is 0 I cap. Now 0 minus minus 2, that is 2 j cap. Now minus 3 minus minus 2, that is minus 1 k cap. Alright, cross, right? What is 4 I cap, right? Plus 5 j cap, alright? Minus 6 k cap, alright? Alright. Now using determinant method, we can calculate this. What is this? Right, we can calculate I cap, j cap, k cap. Alright, what are the coordinates? 0, 2, minus 1. Alright, and here 4, 5, minus 6. 4, 5, minus 6. Alright, that is I cap into, expand this, right? Minus 12, minus 12 plus 5, that is minus 7, right? I cap minus j cap into, alright, that is 0 plus 4, alright, that is 4, right, minus plus k cap into 0 minus 8, that is minus 8, alright, then minus 7 I cap minus 4 j cap, right, plus minus 8 k cap. Alright, so which is the option? Minus 7 I cap, minus 4 j cap, minus 8 cap. Option 3 is correct, right? Alright. Now let us go to another problem. Right. Here another question is given. The x and y, right? The x and y coordinate of the particle at any time, right, are given by x is equal to this, y is equal to this, right? Y is equal to 10t, x is equal to 5t minus 2t square, right? Where x and y is in meters, t is in second. The acceleration of the particle at t is equal to 2 seconds we want to find. Alright? Alright. So what is in 2 dimension here given? X is equal to 5t minus 2t square. 5t minus 2t square. Right. And what is y given? Y is equal to 10t. Right. That is 10t. Alright. Now what is here velocity? Right. See. We want to find acceleration, then double derivative of displacement, right? Displacement in terms of t expressed like this. Then v is equal to dx by dt is equal to 5 minus 4t. Then acceleration is equal to d square x by dt square, that is equal to minus 4. Here what is velocity? dy by dt, that is equal to 10. Then what is acceleration? d square y by dt square, 0. Now what is in 2 dimension in acceleration is equal to, say this is x, this is ay, right? Ax I cap plus ay cap, right? Then what is x? Minus 4 I cap plus 0 I cap. So basically this is the minus 4 I cap, right? So that means magnitude is minus 4 meter per second square. Alright? Alright. Now let us go to another problem. Right. So here it is given P is equal to 2 I cap minus 3 j cap, right? Q is equal to I plus j minus k cap. R is equal to another vector. Then the vector V, right, which is orthogonal to P and Q and having unit scalar product with R can be estimated to be, see, one vector, right, one vector is given, that is V, that V values is given here for option. But what is the condition? That we should produce unit scalar product with R, right, and it should be orthogonal to P and Q, right. So randomly we can check. Suppose first option I am taking. So orthogonal to P and Q means perpendicular to P and Q. Perpendicular to P and Q means we should produce dot product 0 with this V, right. Then let us find it. Then V produce, suppose it is orthogonal to P means what is P? 2 I cap minus 3 j cap. 2 I cap minus 3 j cap. Then what is dot product? Here 3 into 2 6. Here 2 into minus 3. That is minus 6. So then 6 minus 6, this parameter is 0. No k cap component. So this dot product is 0. Then first condition satisfied, right. Now let us think about second condition, right. This is orthogonal to Q or not. This is Q, that is dot product with I cap plus j cap minus k cap, right. Then 3 into 1, 1, 2 into 1 plus 2 minus, right, 3 into 1, that is 3, sorry, 2 into 1, 2, right, 5 into minus 1, that is minus 5. Then divided by 1 4 here, then also this denominator is 0, then dot product 0, then it is orthogonal to Q also. Then two conditions satisfied, right. Now let us check the third condition satisfying or not, right. If it is not satisfying, we will go to the another option, alright. So it produce unit scalar product with R. Scalar product means dot product, okay. What is R? R is 3 I cap minus k cap. 3 I cap minus k cap. Then 3 into 3, that is 9. Now 2 into, here j cap component is not there, then 0. Then next is 5 into minus 1 is minus 5. Then here 1 divided by 4. Then 9 minus 5, 4. 4 by 4, 1. So all the conditions satisfied, right. Then option 1 is correct, alright. Then as first option itself satisfied, we are not interesting to go to the another option, alright. So option 1 is correct, alright. Now let us go to another problem, right. A particle, right, a particle moves so that its position vector is given by R is equal to cos omega t x cap plus sin omega t y cap, alright, where this is omega, right. Omega is a constant. Which of the following is true, alright. So which of the following is true? So let us check one by one. Velocity and acceleration both are perpendicular to R vector. So let us check. So let us go to the board. Look here. Here given R is equal to, so let me take the, so here it is given R is equal to cos omega t x cap plus sin omega t y cap, right. Then velocity and acceleration perpendicular to r, that is given as first option, right. Okay, let us find velocity. What is velocity? Dr by dt, that is what? Omega minus sin omega t x cap, right, plus omega cos omega t y cap, alright. Now what is acceleration? Acceleration is dv by dt, right, that is equal to, again differentiate this, then minus omega square cos omega t x cap plus, right, minus omega square into sin omega t y cap, right. Alright. Now see what is v dot r. V dot r is equal to this minus omega cos omega t sin omega t plus omega sin omega t cos omega t. X cap dot x cap 1, y dot y cap 1. So one term is plus, another term is minus, so that is 0, that is v perpendicular to r, right. Alright. Now second, what about a dot r? We want to check acceleration is perpendicular to r or not. Now what is the dot product between acceleration and this? This become minus omega square cos square omega t plus minus omega square sin square omega t, alright. Alright, then this is minus omega square, that is not equal to 0, that's why a not perpendicular to r, right. So a vector not perpendicular to r vector, right. Then first option is not true, so this is wrong, alright. So let us check the next option. Velocity and acceleration both are parallel, but a velocity is perpendicular, already we seen, so this is also wrong. Velocity is perpendicular to r, this part is true, and acceleration is directed towards the origin. Okay, let us check, right. So again we can go to the board, what we done there. See here. Okay, so acceleration, all right. So what is acceleration? We got a r is equal to, just I am writing that equation, right. R is equal to minus omega square, right. Acceleration is directed towards the origin. What we got? R is equal to, right, R is equal to, we written as cos omega t x cap plus sin omega t y cap, alright. Now velocity, we said acceleration, what we got? Minus omega square into, right, cos omega t x cap plus sin omega t y cap, alright. That means a is equal to minus omega square r, right. So we already differentiated, now accidentally that is missed from the board, alright. So I am directly writing, we already seen what is acceleration. That means from the acceleration minus omega square cos omega t x cap minus omega square sin omega t y cap, there I taken minus omega square out, what is inside the bracket? That is exactly our r. What does it mean? Acceleration is negative of r, means some constant into negative of r, means if acceleration is, you know, r is in this direction, then acceleration is in this direction, right, that negative sign indicate. So velocity is perpendicular to r, but acceleration is directed towards the origin. It is directed towards the origin. R vector is away from the origin. Alright. So this statement is true. Alright. Now fourth option also, velocity is perpendicular to r. This statement is correct. Acceleration is directed away from the origin. That is not true. Because of that negative sign, if r is increasing in this direction, acceleration is directed towards the origin. Alright. Alright. It is just an example of centripetal force. Right. What centripetal force is? See, look here. One circle is here. Right. Now from the origin, the radial vector is away, but acceleration is always towards the center. Centripetal acceleration is always towards the center. Right. Alright. Now let us go to another problem. Right. If vectors A is equal to cos omega t plus sin omega t and B is equal to cos omega t by 2 I cap plus sin omega t by 2 j cap are the functions of time, right? Then the value of t at which they are orthogonal to each other. What is orthogonal? They are perpendicular to each other. Alright. So what I can write? That means, see, this is orthogonal means their product, dot product, right? This dot this, that should be 0. Then what I get? Cos omega t by 2 plus sin omega t by 2 equal to 0. Where dot product is 0. I dot I1, j dot j1, product of sum, right? Now what is cos A cos B plus sin A sin B? That is cos of A minus B, right? Omega t minus omega t by 2. Alright. That should be equal to 0. That should be 0 means omega t minus omega t by 2 is equal to pi by 2. Cos 90 only 0, right? Omega t minus omega t by 2, that is half omega t by 2 equal to pi by 2, right? Then this 2 cancel. Alright. Sorry, half omega t only, right? This 2 cancel. Then t is equal to pi by omega. T is equal to pi by omega. Alright. T is equal to pi by omega. So option 2 is correct, right? Alright. Now let us go to another problem. See, here given another problem. The range of x for which between the vectors A is equal to 2x square, right? 2x square I cap plus 4x j cap plus k cap. B is equal to another vector 7 I cap minus 2 j cap plus x k cap is obtuse is equal to, right? So you have given two vectors, right? So one is this vector A, another vector is this vector B. So the range of this x, here one parameter x is there, here another parameter x is there, right? So both are x. So that x value, so that the angle between these two vectors is obtuse, right? So what is A dot B here, right? What is A dot B? A dot B is equal to say, find A dot B, right? So that is 2x square into 7, that is 14x square, right? Then 4x into minus 2, that is minus 8x, right? Minus 8x. Then plus x, that is equal to 14x square minus 7x, that is 7x into what I can write, x 2x minus 1. Alright. Now angle between them is obtuse, that is given. If angle between them is obtuse means between greater than 90 degree. Theta is greater than 90 degree. If theta is greater than 90 means what is the value of A dot B? Because A dot B is basically mod A mod B cos theta, right? So mod A always positive, mod B always positive. Then if obtuse, cos 90 more than cos 90, cos 120 what? Minus 1 by 2. So this cos theta is negative, that is why A dot B is negative value. That means 7x into 2x minus 1, that is A dot B, that is negative value means that is less than 0. Right. So less than 0 means two condition. If 7x is less than 0, then 2x minus 1 is greater than 0. Then only their product should be less than 0. Alright. Then that means 2x minus 1 is greater than 0 means 2x is greater than 1, x is greater than 1 by 2. Now another condition is there. Suppose 7x value is greater than 0. Then what about 2x minus 1 value? 2x minus 1 value should be less than 0. Why? Their product, this into this should be negative. Then only less than 0 come. Alright. Then what about this x value? 2x less than 0, x less than 1 by 2. What? X greater than 1 by 2, x less than 1 by 2. So both solutions are possible. At a time how x greater than 1 by 2 and x less than 1 by 2? That is not possible, right? So which one of the solution? X less than 0, not possible, right? Now x greater than 1 by 2, that also not appropriate because x greater than 1 by 2 also coming. Then this is right. This is a possible value, right? X is lying between 0 and 1 by 2 is possible, right? So maybe this is x less than 1 by 2, right? X less between 0 and 1 by 2. It is not less than 1 by 2. At a time less than 1 by 2 and greater than 1 by 2 not happen. Alright? Understood? Alright. Now let us go to another problem. Find the resultant force, right? Find the resultant force of the following forces which are acting simultaneously upon a particle 30 Newton due east, 20 Newton due north, 50 Newton due west, 40 Newton due south. Alright. See, that is the resultant. These much forces are acting. Then what is the resultant force? That I want to calculate. See, 30 Newton due east means, so here is east, so 30 Newton in this direction. Now 20 Newton due north, this is 20 Newton north direction, right. Now 50 Newton due west, so opposite of east, that is 50 Newton. Right. Now 40 Newton due south means opposite of north, right? 40 Newton. Now these are in the opposite direction. So resultant will be 40 minus 20, that is downward, that is 20, right? These are in the opposite direction. So 50 minus 30. So the resultant force will be in the direction of higher force. That means 50 minus 30, another 20 in this direction. Right, then what is resultant? Is square root of 20 square plus 20 square. That is what? 20 root 2. 20 root 2. That is resultant. Right? Alright. 20 root 2. That much Newton. Right. Alright. Now let us go to another question. The resultant of two vectors, right, A and B is perpendicular to the vector A and its magnitude is equal to half of the magnitude of the vector B, that is given in the figure. The angle between A and B is. That means, see, look here, the statement is given as the resultant of A and B. First, this is our A, this is our B. The resultant is perpendicular to the vector A. See, so resultant is always acting between A and B, then that is perpendicular to our vector A, right. Now second statement is, and its magnitude is equal to half of the magnitude of vector B. This resultant is equal to half of vector B, right, that also given, right. Okay, the resultant is equal to half of the magnitude of B. The angle between A and B I want to find. Now what is the component? If this angle is beta, what is this component? If this is B, this is B cos beta, right, component of this vector is, because this is adjacent side, so I can write a B cos beta. Then what is B cos beta is our resultant vector. What is resultant? Resultant is B by 2 already mentioned, right. Then BB cancel, then cos beta is equal to 1 by 2, then beta is equal to what? 60 degree, alright. So that is equal to 60 degree, alright. So then what is the angle between? This angle is 60 degree, then this angle is 90 degree, then 90 plus 60, that is the angle between A and B, that is 150 degree, alright. So this is all about this section. Now in the next section we will discuss about a vector triple product, scalar triple product, alright. Thank you.